what we're going to do for the rest of this chapter, we only have two sections remaining, section 6.4, which is this one, and 6.5, which we'll cover on Monday, is we are going to prove triangles similar. Remember that triangles are similar if their angles are congruent and their side lengths are what? Not congruent, but proportional or equal ratios, right? So similarity, the way it's different than congruence, because congruence, remember, was all angles are equal and all side measures are equal. Okay? Similarity is the angle measures are still the same, however, the sides can be proportional. Same shape, but different size. So what we're going to start doing for the rest of this chapter is proving that triangles are similar. One of the theorems that we can use to prove that triangles are similar is the angle-angle postulate. Remember side, angle, side, and angle, angle, side, and all that stuff? Well, if we have two angles that are congruent, then all three angles are congruent. Because if we add angles together, they all have to equal what measure? 180 degrees. So if we know two of them are equal to other, then the third one has to be equal, right? Because that's just the way math adds up. It either adds to be 180 or it doesn't, okay? So if we know two angles are congruent to two in another triangle, then the two triangles are similar. Also, when we write our similarity statement, remember the little squiggle line means similar. You got to make sure you write it in order so that the angles that are congruent to each other are in the same position in their name. So on this one, angle J has two little tick marks. So does X. They're in the same position. K and Y have the same little tick mark, so they're in the same position. So that means L and Z must be equal measures. Does that make sense? Okay, so if I know two angle measures in a triangle are similar to two in another, then these two triangles are similar. So that's what that says. It's on the halfway down the middle of your page. You can highlight that on your theorem sheets. All right. Are these two triangles similar to each other? If so, write a similarity statement. So, what kind of triangles are these? They're right triangles. How do you know they're right triangles? They have a right angle. So we know that D and G are congruent. Right? We know the measure in D and G are the same because they're both 90 degrees. Okay? We also know that C is 26 degrees and angle H is 64 degrees. Are C and H congruent? No. But how can I be sure whether or not these two triangles are similar? But we don't know they're similar yet, so I can't just plug it in. If I add these two and subtract from 180, don't I know the measure of E? Triangle sum theorem? Yeah. So y'all do that for me. What's 90 plus 26, and then subtract that from 180, and what do we get? Nobody wants to participate with me today. You get 64. So likewise, if I add 64 plus 90 and subtract from 180, what am I going to get over here? 26 degrees. So are they similar to each other? Do I have at least two angles that are congruent? Yes. So it says to write, so I'm going to say yes, because I'm answering that question. Are they similar? Yes. But it also says if they are, you must write a similarity statement. So what you're going to do is you're going to draw this triangle symbol here. Triangle symbol here. You need a little squiggle equals before the second triangle. It's not a squiggle equals, it's just a squiggle. Now somebody give me the names of two angles that have equal measure. What? H and E. So I'm going to say E and H. Give me another pair. C and K. And what else? D and G. So when you write your similarity statement, you're saying which two triangles are similar, but you have to put the corresponding angles in the same location in the similarity statement. Does that make sense? Okay, good job. Whoa, this is getting fancy. How many triangles are in this picture? Two. I got the whole thing as a triangle, and then this little top part is a triangle. Y'all see that? And it wants us to show that triangle ABE, which is the little one on top, is similar to triangle ACD, which is the whole thing. So you're basically proving it without making a statements and reasons table. We will eventually get to those. But when it just says show, that's kind of like an informal proof. Okay? So we do need to give reasons, but you don't have to set up the table and do it so formally. All right? So what do we already know from the picture? We know the measures of what two angles? Angle B and angle C. So we can, are they congruent? Yes. So angle B is congruent to angle C. And those are pretty much given to us, right? Right? So if I can show that another angle in each triangle are congruent, then I would have angle-angle postulate, right? Do I know of any other angles? Do what? E and D? I don't know that. Can't assume. Is there an angle that both triangles share? Angle A. Isn't angle A in both triangles? Yep, it's in the little one and it's in the big one. What can I say about angle A? It's congruent to itself. How? Reflexive property. So now do I have two angles that are congruent from each triangle? Yep. So now I can say triangle and make sure that the correct ones that correspond with each other are the ones that work. And that's true because A and A is together and B and C are together. And those are the two that I have congruent. So angle A or triangle ABE is similar to triangle ACD because of the angle-angle postulate. So when it says show, that's kind of like an informal proof. If you want to go ahead and make it a formal proof, we could have absolutely done that because we have our statements and our reasons. Okay? So all you have to do is show me, if you're trying to show they're similar, all you have to do is show me that two angles are congruent. Then you can say they're similar by angle-angle. Boom. Look at that bow tie looking shape. Two triangles. We want to show that triangle SBR, which is the little one on the left-hand side, is similar to triangle UBT, which is the one on the right-hand side. And they show me something in the picture. What do they tell me in the picture? Yeah, SR is parallel to U. Right? That's what those little arrows mean. Those two lines are parallel. So if we know two lines are parallel, doesn't that give us all the parallel line postulates and theorems? Alternate interior angles, alternate exterior angles, corresponding angles. Right? So let's talk about that for a little bit. If these two lines are parallel, this is a transversal and this is a transversal, correct? So give me a pair of angles I can say are congruent to each other. Okay, so that one too, which I'll get to a little bit because those are vertical. But using parallel, S and U. Why are these two congruent to each other? They're alternate interior. So angle S and angle U are alternate interior. And then also, angle V is congruent to angle V on the other triangle because of the vertical angles, right? So angle V, I guess I should have said congruent here instead of and. It's congruent to angle V because of the vertical angles theorem. If I write VAT, do y'all know what I'm talking about? Vertical angles theorem. So now, are they similar? Yes, I have two angles congruent from each triangle. So angle SVR is congruent to triangle UVT by what postulate? Angle, angle. Now we're going to learn two other postulates on Monday that we can also use to prove triangle similar. But right now, all we know is angle, angle. I did put congruent, and I should have put similar. Thank you so much. One squiggle is all I need. Thank you, guys. Okay. Y'all try this one. If you can't read mine, angle C is 32 degrees and angle E is 58 degrees, or you can look at page 382, number 2. Show me that these are similar. You don't have to write it a formal proof. Just give me a few reasons in there, okay? So you got to tell me somehow that two pairs of angles are congruent. Yeah, 58 for angle E. 32 for C, 58 for E. Y'all, what is this angle measure right here? 90 degrees. How do I know that? Not because they're both angle F. It's because they make a linear pair, right? Because if I have two angles together that make a line, then I know that together they are supplementary, correct? So that's why I know that angle CFD, you can't just say because it's beside it. You have to know, that would be the real reason. CFD is 90 degrees because it's a linear pair with another 90 degree angle. So this one's 90. Give me another angle measure I can do. Can't say it. Because they are not. These are not congruent angles. Unless they tell you the word bisector, you cannot say two parts of one angle are congruent. You could have done that back in this one because look, the angle A, it's only one angle A, isn't it? Does that make sense? So that one we could say was congruent to itself, but there is more than one angle D. There's actually three angle Ds. This could be angle D, this could be angle D, or the whole thing could be angle D. Does that make sense? Since we have it split up, we cannot say it's equal to itself. Does that make sense? So, but I can find if I know this is 90 and this is 32, what does this measure? How do you find that? Right, you have 32 plus 90 subtract from 180. So this one's measure is what? 58 degrees, isn't it? Y'all are not talking to me. 58 degrees. And likewise, the other little angle D, if this one's 58 and this one's 90, I subtract from 180. What's this one? 32 degrees. So when I'm labeling those angles, so that's what's that called? The triangle addition property? Angle addition property triangle, or something like that. So, angle D from one triangle is congruent to angle E from another one, right? And obviously, angle F is congruent to angle F because they're both 90 degrees. So now I can say, now y'all, let's be careful with our similarity statement. I got two triangles, one on the left, one on the right. And make sure you put the correct angle with the one it corresponds with. So let's just start with C. So C in the left-hand triangle is congruent to what angle in the second triangle? D. And then F and F are both 90, so you can say they're beside each other. And then angle D in the first triangle is congruent to which one in the second one? E, because they're both 58. And that angle postulate told me that those two triangles are similar. Okay? So you cannot assume congruence unless you know measures or it tells you the word bisect or something like that if it's split up. Does that make sense? I think we're going to skip this. Oh, it's 11 o'clock. I think we are. Section 6.3. Yes, we are. It's a flagpole. We're skipping it. We are done with today's lesson. That was section 6.4. Have a good day.